Okay, today we're going to be looking at proportions on triangles, but in a little bit different way, because we want to compare the sides, and yet we might not be comparing them exactly to a triangle. There's a rule called the side splitter, and you can split a triangle anywhere on the side. It doesn't have to be in the middle. Now when you do that, they have to be proportional to each other, how you split them, because the line at the bottom is parallel to the bottom of this other triangle. So since these two are parallel here, this splitter splits your problem. Now, really, I'm comparing a triangle to a trapezoid measurement, because 7.5 is on this triangle, but X is on this trapezoid. But because we're using parallel lines, we can say they're proportional and compare a side on a triangle to a side on a trapezoid. But you have to do both of them. So if I gave you information about the bottom of this triangle, I could not use it at all to find the answer. So we're going to put this in our vocabulary to represent this side splitter theorem that says a line is parallel to one side of a triangle and intersects the other side, then it divides those sides proportionally. And so I can use 7.5 over x, because that's the triangle over the trapezoid, to 6 over 3, which is a triangle over the trapezoid. At least I am comparing them in the same way. So I can go 6 times x is 6x, and 3 times 7.5 is 5 carry 1, 22.5. Then I can divide by 6 to find my x. Let's see, that'll be long division. 6 goes into 22.5. 6 goes into 22 3 times. That's 18. Subtract and left 4 over. 6 goes into 45 7 times. That's 42. That'll be 3 left over. This might keep dividing out for a long time. We'll see. It goes into 35 times evenly. Nope, it ends right there. 3.75. So side splitter works really well. So on the next page, I have a couple of side splitter problems for you to set up. The solving part is the same thing we have been discussing. It's just a matter of when you split the side, you can compare the triangle to the trapezoid, where before we would have had to say 8 over the total length of the side. Now we can do side splitter and not have to do that because we have it on both sides of the triangle. So stop your video now and use your whiteboard to work these two questions. Then come back and check your answers in a few minutes. So now that you're back, let's see if you set it up right. So 8 and 10 is triangle over trapezoid. Be compared to 6 over x, because 6 and 8 are the tops and they're both on the triangle, and 10 and x are below the side splitter, which means they're on the trapezoid. So if we go 8 times x is 8x, and 6 times 10 is 60, that cross multiply actually ends up being a divide next, because we can divide 8 into 60. Now if 8 doesn't go into 60 evenly, which it doesn't, sometimes you may find it's not a very good answer. Sometimes it may be. You can't write repeating decimals. You can write like short decimals, like that 3.75 we had earlier. So if you take 60 divided by 8 on your calculator, and you get a short decimal, what we call terminating decimal, we can write it. I got 7.5, so I can write that. That's a short terminating decimal. Now over here, 12 and 9 are your two, but 9's on the triangle and 12 is on the trapezoid at the bottom. We can compare that to x plus 4, which is on the triangle, because triangle to triangle can be measured as the tops. And then the 2x and the 12 are both on the bottom below the side splitter, so that means they can go on the bottom of the fraction. Now, this problem is not going to be just cross multiply and divide. We're going to cross multiply and get 18x. We're going to go 12 times both of these, so it's going to be distributive because you got to do 12 times everybody who's across from him, and that'll be 12x plus 48. Then you can subtract 12x to bring all your x's to the left, which is very important in mathematics to have your x's on the left. So how much does that make? 6x. So now I can divide by 6, and 6 goes evenly into 48 8 times. Now the question here did not tell me to find like the length of a missing side or anything, so I'm just stopping with finding x because I'm assuming that's all they asked me to find, and I would stop. Now, sometimes you might be asked to go back and find the measurements, and you'd have to plug that 8 in, but not in this case. We have another rule about side splitters for you to put in your vocabulary. If 3 parallel lines intersect 2 transversals, then the segments separated on the transversals are proportional. So here I have 3 parallel lines, 2 totally different transversals. But because the distance between these has to be proportional because the lines are parallel, we can say A over B equals C over D. And that allows us to compare trapezoids to trapezoids, because if you look at it, that's what we have. We have a trapezoid here on top between those 2 parallel lines, and we're comparing it to a trapezoid down here between those 2 parallel lines. And so because they're both trapezoids, we can make proportions by using the measurements in between parallel lines. So you need to copy this vocabulary down and then restart your video. So now, in looking for the answers to this question at the right of completing each proportion, let's go through and see which ones you can figure out go together because of where they're located. So A and B are in one fraction. There are these 2. It says compare it to E, so the only other one that could be with it has to be, and that's right, it's D. Then if you do the same thing again, if you look at marking what you have, it'll be obvious how they're compared. B is compared to something, but E and F is being compared. So it's obvious if E and F are compared, B has to go with C because they're in the same position as E and F. So in this last one, it says A over B plus C. Okay, so let's look at where that's located. So I'm comparing A to this whole length here. It says compare E and F added together. So I've got the 2 parts that are being added together. I just need the other part that goes with A, which is D. So you can even make longer segments out of it if you have more parallel lines. You don't have to just say the 3 parallel lines make 2 sets of proportions. There are many proportions we could set up with 3 or 4 or 5 parallel lines cut by many transversals. So stop the video and set up these and see if you can figure out how much each of these would be for the side splitter rules. So let's check your paper. So on this side I have 4 over 6. So this splits my problem right there. So I have to compare it to 5 over x because that transversal on each side is split by one of the parallel lines. So if I cross multiply, I get 4x equals 6 times 5 is 30. Now 4 is not going to go into 30 evenly. So I could try dividing it on the calculator and see what I get. Or I could reduce this and say this is 15 over 2. And I know what that divides out to give, 7.5. So I either can use my calculator or I can use my brain. It's all up to what you can see in your problem. I saw that reduced, so I thought fractions, And then I said I can divide 2 into 15 much easier than I can 4 into 30 necessarily, because it goes 7 times with 1 left over. And that'd be 7.5, which is 7.5. Now on this one, our side splitter is going this direction because it has to be one of the parallel lines. So I'm going to compare 8 over 12. But I bet you're wondering, well, what do I do about this space right here? There's nothing written there. Yet they told us the length of the whole thing is 24, and this little piece right here is x. So you know you're going to put x over the question mark, but the question is, how are you going to find it? You can't have x over question mark. Well, if you knew this x, for example, if x was 5, wouldn't you take 5 away from 24 and find that measurement? Or if x was 11, wouldn't you take 11 from 24? So this measurement is 24 minus x. I don't know what x is, but I know I'd take it away from 24 to get the other piece. So I put this as x over 24 minus x. That gives me a great proportion that I can solve. I can do 12 times x and 8 times 24 minus x. So 8 times 24, 8 times 4 is 32, carry a 3. 8 and 2 is 16, and 3 is 19. 8 times x is negative 8x. So that 8x has got to come to the other side, so we're going to add 8x to both sides to get rid of subtraction of 8x. That gives me 20x equals 192. Now, 20 ends in a 0, so the other number has to end in a 5 or a 0. Usually for things to divide evenly, it would need a 0. It doesn't have a 0, so I would either divide this on my calculator, or I could try taking the question and seeing if it would reduce. But this is a little bit larger, so I'm just going to divide it on the calculator and get 9.6 exactly. So it's good. It's a short terminating decimal. So that one's a little tricky because it expected you to understand how to fill in a hole in a chart, and you may not have thought about doing that. You may not have thought about how x plus 24 minus x adds up to 24. So your third thing to put in your vocabulary, so switch back to vocabulary now. You want to put this in because this is an angle bisector theorem, which is a really good one. It helps you to take a ray. It doesn't have to make a right angle where it bisects, luckily. So you have, it's perpendicular right here, but the other corner could be any angle. And it says when you do that, it divides the two sides that is across from into two segments that are proportional to the other sides of the triangle. So it's kind of like if you divide this angle in half, then you've divided that long side of this obtuse triangle into two pieces. And you can compare the two 5 over 6 and 8 over x. You can compare them on the same picture. Or you could say 5 over 8 equals 6 over x. That's another possibility. 5 over 8 equals 6 over x. Because if you look at these two, don't they have the same diagonals? So you can either take the two off of the same side of the line, or you can let the line to be your division so that you can say that it's 5 over 8 because they're both on the same side of the picture, but yet have that division line between them. So that's going to be 5x equals 48. 5 goes into 48. 9 times. That would leave me with 45 and 3 left over. If I add a point, it'll go 6 times. So I can do long division sometimes. You need to be practicing these skills of how to do long division, reduce fractions, whatever might work to get the answer without having to every time type it in the calculator to cross multiply and divide. Because colleges are looking for students who can do math by hand and not have to have a calculator to do everything. And if you don't practice these skills, you won't have them. So once you finish copying this vocabulary, if you have not finished it right now, stop the video, and finish writing down this vocabulary. And then work the two problems on the next page. So with our angle splitter, if you draw the line, then it divides the picture up for you and makes the proportion x over 5 as in 12 to 10. Now in this case, when I look at this problem, I think fractions. You don't have to cross multiply and divide. Don't you see that's just times 2? So what do you times 2 to get 12? That's another way of solving a proportion problem. If you looks like that you could reduce 12 over 10 and it's going to become something over 5, I'd do that. Or think of it like this. I doubled 5 to get 10, so what did I double to get that? I doubled it 6 to get 12. But if I cross multiply and divide, it works the same way, because I have 10 times x, 5 times that's 12 is 60. So since 5 times 12 is 60, doesn't 10 go into 60 6 times? Same answer, just a different way of getting it. Not every problem has to be cross multiply and divide. So with our next example, if we draw this line in, did you set it up with 8 over 5 on one of your fractions and x over 3 for the other? Or did you say 3 over x and 5 over 8? There wouldn't be anything wrong with starting at the bottom. I just usually like to start at the top. You also could put probably 5 over 3 and 8 over x as another example. But I usually just let the line do my dividing for me and just do one number on each side of the line is your first fraction, and do the other fraction in the same order. So I did the right picture over the left picture. Now I'm going to cross multiply. 5x equals 24. Now 5 doesn't go into 24 evenly. Let's come over here and do that long division again. 5 goes in there 4 times. I got 4 left over, so let's add a point and bring down a 0. 5 goes into 48 times evenly. So it's 4.8. So in this last picture, they're asking you to do this with letters. So this is kind of like what we did before, where you look at the picture and try to find something in the same position. So RS and JR, that's these two segments. So we're looking at the different segments that have been cut up. This is KJ. KJ is this one. So what is the one on the opposite side of the picture? That's right. It'll be KS. Now, when you mark pictures like this, you'll have to go back and you will have to erase and start again. So KJ and KS, well, we just used those two. But this time they'll want us to compare it to JP. JP is this mark. So what's on the opposite side of the picture from that? Well, I can't use that middle line this time. I have to use, that's right, I have to use SQ. So with our next example, the first one says KP, so that's all the way to here. The next one says LQ, which is this little piece right here, and KQ, which is this piece over here. So as you see, I'm looking for this piece here that is from K to Q is the same piece as the one on the opposite side. So I just need to find what's opposite QL, which happens to be PM. Now I did those letters backwards. Let me go back and refresh my memory here. It was from L to Q, so I have to start from M to P. That is very important. You want your letters to go in the same direction. So when I did JP, which was from left to right, I had to use SQ because that's left to right on the line. Make sure you put them in the right order based on what the other one order would be for your picture. Because sometimes they don't put them in alphabetical order. Sometimes they put them in the order they're on the picture, like SQ. Alright, so you now should have enough information to help you to do the worksheet on this lesson, because that was our last slide. So I hope you got the notes down in your toolkit. You were supposed to have 3 pages of vocabulary and have looked at some of these questions with your whiteboard.